Okay. Another type of classification for variables. Okay. The first way we classify variables is like this one. Variable classified as quantitative or qualitative. For quantitative variable, it can further classify as discrete or continuous. Okay. Now, this is first type of classification we just introduced. And another type of classification for variable, we classify variable according to what? Level of measurement. Okay. And there are 4 different level of measurement. First one, the nominal level. Second one, the ordinal level. Okay. And the third one, interval level. And the last one, ratio level. We're going to introduce you one by one. Okay. Begin with the first one. The nominal level of measurement classify data into mutually exclusive. Please highlight this one. Mutually exclusive, denoted by ME. Okay? Mutually exclusive. Or you say non-overlapping. Exhausting what? Categories. This is a second keyword, exhausting. In which no order or ranking can be imposed on the data. No order or ranking. This is what? The third place you should highlight. And to explain those important features, let's look at example. Zip code, gender, eyes color. They are nominal level measurements. Okay. Now, let's use gender as example. Variable gender. It has only 2 possible values, male or female. And first feature, mutually exclusive. What is mutually exclusive? Well, very simple idea. If you are a male, then you are not female. No common part, okay? If you are not a male, if you are a male, you are not a female, okay? That's mutually exclusive. Or you say, if you are a female, then you are not a male. That's called mutually exclusive. And second feature, exhausting. Exhausting means what? Nothing left uncovered, okay? If you are a human being, then you can be male or you are female, okay?
Okay.
Together give you all possible value of what? Give you all possible value of gender can have, okay? That's 2. And what's the third one? Third one is no order or ranking can be imposed on the data. No order or ranking. That means you can never say male is a better gender than female. Or you say female is a superior gender than male. Nothing like that. No order or ranking. They just different. Okay? So
Hello.
any variable satisfy these 3 features, mutually exclusive, exhausting, and what? No order or ranking.
Hello. Oye.
That is what? That is nominal level data. Okay? You want to copy? Go ahead. You have 3 minutes. And memorize the definition as well.
Lovely bhai.
The ordinal level of measurement classify data into categories that can be ranked. However, precise differences between the ranks do not exist. What does that mean? Okay. Now, the relationship between ordinal level and nominal level is ordinal level is a more advanced level. Everything nominal level has, it also has, okay? It also has. And it has some more advanced feature that nominal level doesn't have, okay? For example, no order or ranking can be imposed on the data. That's for nominal level. But when you come to what? Ordinal level, data can be ranked, okay? Data can be ranked. So let's check here. To explain the idea, we use what? Letter grades, okay? Letter grades. First one, mutually exclusive. And second one, exhausting. Grades, letter grades, okay? If you take a course, you can only add up with A, B, C, D, and what? F. In covalent college, we don't have E, we have D, okay? A, B, C, D, F. Nothing left uncovered. That's called exhausting. What's mutually exclusive? If you got an A, that means you don't get what? B, C, D, E. If you got a B, you don't get A, C, D, E. If you get F, that means you don't pass the course. Okay? You can only get one. This is mutually exclusive. It's exhausting. Now, data can be ranked. Okay? Can be ranked. What is a rank? That means A is better than B. B is better than C. C is better than D. And F is the worst one you can get. Okay? Data can be ranked. So if I say no order or ranking is 3, data can be ranked is called 3 prime. Okay? You want to copy this one? You have 2 minutes. Go ahead. Okay, look at here. The interval level. Oh, there's one thing I haven't covered here. However, precise differences between what? The ranks do not exist. What does that mean? This is a false feature. So what does that mean? Okay, precise differences between the ranks, or you say 2 given possible values, do not exist. What does that mean? Let me use letter grades as an example to explain. 3 students in my class, Peter, Yuki, and Eric. Okay? grades. Peter get what? Peter get C. Yuki get A. Eric also get A. You know, Yuki is better than Peter. But how much better? You don't know, because precise difference between the ranks do not exist, or the precise difference between two possible values do not exist. Not just that. If Eric get A, Yuki also get A. Who is a better student? Okay, who is a better student? You also don't know. Okay, you also don't know. Now, if I use percentage, why Peter get C? Because Peter gets 64% on the coursework. And Yuki get A because Yuki get what? 86% on the course. Why Eric get A? Because Eric get 90%. Or you say 89%, okay? If you look at the grade only, you know Yuki is better than Peter, but how much better, you don't know. But if you look at the percentage, Yuki get A because he got what? 86%. Peter gets C because Peter got 64%. And you know this is a better grade, a bit better score than this one. Okay, better score than this one. And how much better? Well, 86 minus 64. That's what? That's 24%. So let me show you the graph. Okay, let me show you the graph. This is a score. In what? In percentage. Okay, score in percentage. C is Peter. Peter's grade. Okay, Peter gets 64%. A, Yuki. Yuki get what? 86%. And Eric also get A. Eric get what? 89%. So look at here. If I measure performance by using score in percentage, two different score will determine what? An interval. And the precise difference between these two scores is the length of the interval. Okay? If I use what? Score. If I use score, okay? Two possible value. Or you say score in percentage will determine an interval. And the precise difference between two score is the length of the interval. Okay? So that's why we say grades or letter grades. We can tell which one is a better grades, but precise difference, A is better than C. But how much better? We don't know. This is ordinal level. Okay? But test score in percentage, 86 is better than 64. But how much better? 86 minus 64, the length of the interval. So score in percentage, this is called interval level. Okay, this is called interval level. If you want to copy, go ahead. You have what? You want to copy? Go ahead. You have 3 minutes. Okay, copy this. You want to copy? Still have 30 seconds. Okay, let's look at the last one. We know what's interval level already. What's the ratio level? Let's read the paragraph. The interval level of measurement ranks the data and precise difference between what? Units of measure do exist. Everything ordinal level has, interval level also has, okay? But interval level has more advanced features. However, there is no what? Meaningful zero. Meaningful zero, highlight this, okay? Now, look at here, what's the ratio level? The ratio level of measurement possess all the characteristics of interval level measurement, and there exists a true zero. So you can see the difference. Interval level don't have a true zero, but ratio level has a true zero. Okay. To explain what's a true zero, what is don't have a true zero. Okay. Let's look at temperature as an example. Say outside, the temperature. The temperature outside, say, is what? 9 degrees Celsius. Midnight tonight, it can drop to 0 degrees Celsius. Okay? And when you drop down to 0 degrees Celsius, can you say outside has no temperature? So this is 0. It's not a true 0. Let's try one more time. Outside right now is 9 degrees Celsius. Midnight tonight, it can drop down to 0 degrees Celsius. When you drop down to 0 degrees Celsius, can you say outside has no temperature? Of course not, right? When we say 0, it's just compared to this one, it's 9 degrees Celsius below, okay? But doesn't mean outside has no temperature, okay? So this is not a true 0. So temperature measured in degree of Celsius, this is what? This is an interval level. Okay, interval level. Ratio level exists a true 0. Let's use salary, okay? Say Peter did not work last year. Okay, so his salary last year is what? Is 0. This 0 is what? Is a true 0. That means Peter did not get any money to his pocket through working. Okay, this is what? This is a true 0. Okay, you want to copy? Go ahead. Give you what? 3 minutes. Okay, today I'm going to take a little bit longer, probably another 5 minutes to finish the topic. Okay, go ahead. Okay, look at here. Say this is 0 degrees Celsius. Okay, 0 degrees Celsius. Temperature measured in Celsius. Okay. We know this is not a true 0. And some people may notice in physics, okay, you probably studied this. If you measure the temperature, there's another one unit you can use. 0 degree Kelvin, which is equal to minus 273 degrees Celsius. Okay, listen, 0 degree Kelvin. This is a true 0. Okay, this is a true 0. Why this is true 0? Because our every material in our universe come to this low temperature, everything freezes. Okay. So this is a true 0. This is not a true 0. Since this is not a true 0, think about this. 1 degree Celsius, and this is 2 degrees Celsius. Since this is not a true 0, we cannot say we cannot say what? We cannot say 2 degrees Celsius is twice hotter than what? 1 degree Celsius. Because this is not what? Not a true 0. Okay? As you can see from the picture, from here to the true 0 is this much. From 1 degree Celsius to the true 0 is this much. This is not 2 times hotter than this. Can you see that? So when you don't have a true 0, the number is not in the correct ratio. So this is not ratio level. This is interval level. Why? Because degree Celsius, 0 degree Celsius is not a true zero. Okay? Then how people invent this? Well, you know, if you read in the high school, 0 degree Celsius is a temperature what? Huh? Water become hot ice. Right? And what is 100 degrees Celsius? This is a boiling point. And from here to here, from 100 degrees Celsius to 0 degrees Celsius, we subdivide it into what? 100 equal intervals. Each one is 1 degree, okay? Since this is not true zero, you can never say 2 degrees Celsius is 2 times hotter than 1 degree Celsius. That's wrong. Now, if you measure temperature by Kelvin, say this is 50 degree Kelvin, and this is 100 degree Kelvin. You can say 100 degree Kelvin is what? Twice hotter than what? 50 degree what? Kelvin. Because this is true zero. This is what? 2 times longer than that. The measurement, they are in correct ratio. So when you measure temperature in Kelvin, it has a true zero. So that's what? That's ratio level. Okay. If you want to copy, you have 3 minutes. Okay, go ahead.